Yeah, I still have that jacket here. It protects me from making mistakes in artificial intelligence. Hopefully. Yep. Thank you. Welcome to the channel again. My name is Davison. I'm a software developer. Today we're talking about Brian Christian. He's got a book called The Alignment Problem. And we find this book very fascinating. It's got a lot of information. It's a bit discouraging, but it's full of facts and actual experiences. Why is it discouraging? Because it really shows that you cannot divorce machines, even artificial intelligence, when you train it based on human data that is coming from people's behavior, people's experiences, actual data from actual people living their actual lives in society. Then in that data there will be biases, there will be prejudices, there will be positive things, negative things, the full human picture, which is full of joys and pains and celebrations, successes and failures. So it's a whole rainbow of behavior that's in that data. However, that data has prejudice. I wouldn't call it prejudice, but bias. And bias is really nothing to do with race per se. It's really bias to do with preferences that are ingrained in people, ingrained when they make decisions as individuals, even sometimes as groups. There are certain words, certain colors, certain that transmit a positive sometimes attitude, depending on who is the subject and who is the object, and also negative behavior. And therefore, when people then we then record that behavior, it becomes data, and we try to make a machine learn from that data. It will automatically pick up those nuances and transmit them. In fact, when we do rewarding, you can call the word they use is reward hacking. But as software developers, we use this method where we reward for a model for achieving a certain threshold. But you find that the model will simply find the shortest route to that score, to that reward. And of course, it will not have no qualms about it. It will be prejudiced or biased. It doesn't sort of like avoid bias, so to speak. You'll actually find the bias because it's not aware that it's bias. It will just use the data and find and plot a way to the shortest way to that goal. So therefore, it's a very interesting book. Let's please enjoy the video. See what you think, and at the end of the video, you can make comments if you wish, and also share your own experiences. Thank you. We are looking at the book The Alignment Problem by Brian Christian, which is basically a book that states that it is very difficult for you to divorce engineering, machine learning, software development, especially intelligence, like artificial intelligence, which is coming out of human experience. It is very difficult to divorce it from society. I hereby take a quote from the book which you are seeing on the screen. Essentially, engineering is all about cooperation, collaboration, and empathy for both your colleagues and your customers. If somebody told you that engineering is a field or was a field where you could get away with not dealing with people or feelings, then I'm very sorry, you've been lied to. So this book really says that when you are training a model, you are training it on data, and that data is basically a record of people's behavior, and that people's behavior is affected or influenced to a very large degree by their biases, their beliefs, their concerns, their behavior, which has been molded over a long period of time. And therefore, if you are to expect that new things that are not in those people, in those societies, are going to emerge out of that data, you are sorely mistaken. So there is always a situation, as can be seen on the screen, where the customer is requesting for A and then hoping for B. Like in the case that's outlined on the screen, you are developing a game and you are vaguely saying, the game, the model must learn how to win. And yet, you did not specify the win. You simply said maximize the score. So in order to maximize the score, the model will just iterate in one place and continue to circle in that one place, because it has worked out that by moving around in that one place, it can maximize the score. And therefore, the goal that you have set and what you're actually doing on the ground, there's a disconnect. In a similar way, here in South Africa, we had an organization that was a public sector organization that was basically giving money to indigent low-income families. And it was intending to give that money fairly to all families, but it ended up having a bias where most of the money was being given to families which had which were represented by a female applicant, because the system prioritized the word single mother, because in most cases single mother tended to be unemployed, or in most cases, and therefore it had the bias that in most cases it would give those funds to those single mothers who are unemployed. And yet you would find that there are some single fathers who are head of the household and are unemployed, and therefore there's a higher impact if they are not given any funds. Yet the woman or the female that might be unemployed has got a husband at home who is working, and therefore might not be in such a dire straits. So this was something they intended to address by training the model, but the model was just simply learning the same patterns of what they had been doing over the period of years, and it quickly picked up that the word single mother was aligned with unemployment, and therefore used the same logic to achieve the same ends. So what we ended up having to do is to change the word single mother to single parent, so that it would then be not completely aligned to unemployment, but the data would be more balanced, because some of those single parents would be male, some of those single parents would be female, so there would not be necessarily a higher percentage of a particular gender being unemployed, and therefore those funds would then be equally dispersed to all applicants who were unemployed and who were breadwinners or the sole breadwinner in the family. So that's an example of an alignment problem that we solved. If you look at this diagram, it represents basically our experiences in South Africa regarding the alignment problem. Our data normally, in most cases, when we deal with teams that are trying to implement a system that is new behavior, explicitly, so to speak, because normally they speak in tongues, to put it technically. They speak of what they are wishing to do, and then they give you the old data, and that doesn't work, because whatever they are wishing to do, especially if it's a new behavior, a new plan, a new strategy, it is normally not in the historical data. So what we normally do is to either find that behavior in the historical data if there's any chance that it might be there, or we import new data that contains that behavior. Then through primary keys try to link it to the table so that it can be introduced into the data, which is quite difficult. Or the other method is to get an LLM that exhibits that new behavior, and then we train that LLM using the historical data. So we're basically adding that data to the LLM's portfolio, so to speak, of abilities and knowledge, right? So these are the three sort of like ways in which we've been able to defeat the alignment problem. If you can look at these arrows, they actually show the constitution of operation, meaning if you look at the historical data, it only flows upward into the LLM. It never flows from the LLM down, because that's not possible. Another arrow that you're looking at is from the historical data, you're going to the augmenting data, and again, it doesn't flow up. We don't have a situation where we are pushing any data into the historical data. That is a no-no. We actually get either the historical data into the augmenting data, we enrich that in augmenting data, or we link it with primary keys and whatnot. And the other third option is actually to introduce the new required behavior at a low level in a small scale, smaller strategy, and then introduce it into the database and start actually capturing data and use that little data set as an example, a pro forma of what is required. So anyway, you can see that the alignment problem is really a challenge if you can identify it, because normally people don't even know it's a problem. They don't identify it. They just see a problem without definition, without explicitly tracking where the problem is coming from. The team is just saying it's not working, it's not what we want, that kind of thing.